First of all, ASKO as a wholesaler, we have three ambitions. So we want to have efficient logistics to satisfy customers, competitive supply chain, and we need to be sustainable and climate neutral. So when we started to look into how to kind of exceed and expand and meet the demands in the market, we looked into in 2016 to see what would be the best solution for us. So we did a big inventory and also a big business case, and where we measured a manual operation, as we kind of are very experienced in having, and to an automated solution. And when we kind of compared those two solutions, we saw that the return of interest was best for the automated solution. And we looked in the market, and we ended up with a SCHÄFER installation for both ambient and frozen goods.
So from a logistical point of view, we had a challenge of two big topics. The first topic was we have a very high throughput on a very limited footprint and a plot, so we have to distribute all those logistical functionalities onto multiple levels. So it gets very complex to have the performance outcoming from this small footprint. And the second challenge was dealing with multiple temperature zones, so deep freeze, ambient, as well as chilled cross-dock, and bringing all those together just in time at the docks for multi-chamber trucks. So this is a very specific use case we had to deal with.
Firstly, we see a good return on investment. Kind of the business case as such is good. In Norway, we have a very high payment for the employees. It means that it's costly to have laborers working in the warehouse. On the same time, it's difficult because it's not that many people that want to work in the warehouse. And automation solves a double issue there. And we have a better quality. As you can see from behind us, you can see kind of the dealing. We handle the cases in a very soft way, so to speak, and we kind of make sure that we deliver all what the customer requires. Our automated warehouse, of course, manual as well. We can work around the clock, but the robots they don't eat, they don't sleep. They can just, as long as we maintain them, they will kind of run the whole system every day, every night. And we got a very low cost for the SKUs. Every column we pick, it's cost efficient. And the whole kind of investment is to make sure that we hold a position as #1 supplier in Norway, and we get the best performance for our customers as well.
So we try to do as much as possible with the robots. So we have to separate ambient area, chilled area, and frozen area. Chilled was mainly driven by cross-dock and consolidation, so there is no specific robot. When we talk about case handling robots, of course there are robots and automation done by conveyors and stacker cranes. But an ambient environment, we had automated depalletizing robots, so we're picking layer by layer from the overstock pallets and then singleize them and store them in a shuttle system, in a 3D shuttle matrix system, and then sequence them in the right sequence to bring it again to a robot cell, to our automated palletizing robot cell, where we then build up, like Tetris, the customer-specific pallets and bring all different cases together for one pallet for one store. And in the frozen environment, because the throughput was not that big as, for example, in ambient, we still go to automated palletizing robot cells, but on the depalletizing side, we choose to go with a manual operation. So we have Vamas there as a WCS handling all the planning and also MFS with the transport coordination. And when it comes to the robot control and the vision, then there is Vamas Robotics. So all house-made software tools are used to build up this full process. And when we talk about performances we achieved there, we talk about 600 cases an hour per palletizing cell. And on the depalletizing cell, we talk, depending on the cases per layer, somewhere between 1,800 to 2,000 cases an hour. I think that you have to step away and not just have a look on the robot and the robot arm itself. You have to take also care about the surroundings of the robot and the interaction of the robot. I think it's quite easy to place a robot next to a conveyor, but it's very difficult, the cooperation between the robot and the surroundings and all exception handlings and the security stuff which comes with that. So I think that's the very most challenging point to bring robots into existing solutions. So I think a better way would be to make it a step back and not just have a focus on the robot, but also including the surroundings within the robot cell. So to be more independent and then have it more plug and play and then add to an existing logistics solution. I think this would be the way forward.
I think also from our side as a customer, we had some discussion on kind of operating warehouses. It's difficult to kind of install that in an ongoing process. You more or less need to make a full process on describing how to use this, and just don't take a component from there and there. Just make the whole solution. Yep. So our lesson learned so far is that if you want to do a massive automation, you need to kind of think bigger than just existing plot. That's our experience at least.